All right, you guys, today we are doing proofs with parallel lines more. And where I'm starting this off is in example 1, I'm saying which lines or segments are parallel. State the postulate or the theorem that justifies your answer. So what I want to remind you is that we're trying to prove that we have these parallel pathways. So that means that if our starting point is the angle relationship and we're trying to prove why we have parallel pathways, that means that we are citing a converse. We are using the converses here today. So keep that in mind. We are starting with an angle relationship and we're building towards these parallel pathways. So in my first example, I have two angles that are marked. So here are the two angles, and we're seeing, does that create a parallel pathway? If it does, what would be the parallels? So I'm going to use a red pencil to mark the potential parallels right here. And then what would be the transversal? That would have to be right here. So what kind of angles am I given? Well, I'm given right here that these are two corresponding angles that are congruent. And if I have corresponding angles that are congruent, then yes, my pathways are running parallel. So I can say that RW runs parallel with CN, and my reason would be the converse of the corresponding angles postulate. All right, so they do run parallel, okay, because of the converse of the corresponding angles postulate. We know that corresponding angles are congruent. That leads us to our lines being locked into a parallel position. Okay, my next one here, I have angles here and here that are marked congruent. So if I'm trying to sandwich those angles in and show that I have some parallels and a transversal, well, that has to be here, and here would be my parallel pathways, only if this is my transversal. So if I go back and I look at the angles that are marked here and here, those are congruent angles. What angles are they if I'm highlighting these three pathways? I should see that, oh, they're alternate interior angles. So if I have alternate interior angles that are congruent, then yes, that will lock my pathways into a parallel position. So here I can say that BR runs parallel. So BR runs parallel to OW. Okay, if I had written that as WO, that would be fine as well. Okay, my reason here again would be a converse. So converse of the alternate interior angles theorem. All right, looking at the next one here, I'm trying to figure out what would be my parallels, what would be my transversal based on the angles that are marked, and it would have to be this pathway right here and this pathway here, with this transversal. So if I look at those two angles that are marked as congruent, what kind of angles are they? Well, again, they're alternate interior angles, which would mean that OR would run parallel to NC. And my reason here would be the same as it was for the last one, we're looking at the converse of the alternate interior angles theorem. Because we have the alternate interior angles that are congruent, that is what locks our lines into a parallel position. Okay, in my next diagram, I have these two angles marked. So here it's a little easier for me to see then that it must be this pathway that we're trying to see if it runs parallel to this one, with line A as the transversal. So W really has nothing to do with it. You've heard me say quite a few times, block out the noise. So if it helps you block out the noise, block it out of view, that's fine too. So if I look at the angles marked, what kind of angles are they? They are alternate exterior angles, and because they are congruent, lines C and L must run parallel. So here I'm going to write this as line C runs parallel to line L, right? A would be its transversal, and my reason would be the converse. They're all converses. So converse of the alternate exterior angles theorem. All right, next one. So here I'm looking at these two angles as my starting point. So what would have to be the pathways that are going to sandwich those angles? Well, it would have to be here, this pathway, and this pathway would be the ones that potentially run parallel with this transversal. So if I look at the angles that are marked, what kind of angles are they? They are alternate interior angles. We've seen a few of those today, right? That's usually the common relationship that we see in this style of proofs is, do we see alternate interior angles? We do. And because we have alternate interior angles that are congruent, that is what is creating a parallel pathway. So here I can say that PL runs parallel to NE. And our reason would be the converse of the alternate interior angles theorem. All right, and then lastly here in F, I wanted to mark a pair of angles, so let me add that to my picture. So let's say that I'm giving you this angle here, congruent to this angle here. All right, so again, I'm trying to see which pathways would sandwich those angles. Well, it would have to be right here and here. Those pathways would have to be my parallels. Okay, with this blue as my transversal, only if I have the right angle relationship. So those two angles that I have marked, those are congruent angles. They are corresponding angles. And since I have corresponding angles that are congruent, then my pathways are running parallel. So I can say that FM is parallel to AR. And my reason would be the converse of the corresponding angles postulate. All right, so that whole example was really getting us ready for writing our formal proofs. So we have two that we're going to do today. Let me slide on up. All right, so in any proof, we're always building off of prior knowledge. And here we're given two statements. Our starting point is that we have two pairs of angles that are congruent, and we're trying to build to why is it that these are parallel pathways. So if we're trying to get to parallel pathways, we have to connect a pair of angles first. And since I always like to kind of visualize what is it that I need to ultimately connect, well, I'm trying to show that FR here, this pathway, runs parallel to this pathway. That's what I'm trying to build up to. So if I look at my angles marked, then I know that this right here would have to be the transversal that's going to get me there. So I know that ultimately, to get to those being parallel pathways, I need to connect angles 1 and 4. All right, so let's start with what we are given. Now, I've said this a couple of times. Sometimes we split up the givens and sometimes we lump them together. I see no reason to not lump them together this time. So I'm going to say that angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4. All of that information is given to me. So if I go to my diagram, I can mark that angle 1 is congruent to angle 3. So I'll give it a single tick mark. And then I also know that angle 2, I'll give it a double, is congruent to angle 4. So that's my starting point right now. So now I'm looking for another relationship and I see, oh, look at those vertical angles. I know that vertical angles are congruent. So in my next step, I'm going to say, okay, well, angle 3 is congruent to angle 2 also. That's the vertical angles theorem. So if we can identify vertical angles, we know that the relationship is that they're going to be congruent. Okay. So if 3 and 2 are congruent, well then I might as well give 3 a little tick mark and 1 another tick mark here so that everything gets 2 tick marks. So now I just have to explicitly state that 1 has to be connected back to 4. So if I look at why that's true, well, if I've connected 1 to 3, and I've connected 3 to 2, and then 2 to 4, well, I can finish off that chain using substitution. If you argued transitive property, I would take that as well. So transitive is 3 or more connections. Substitution, we are seeing, let me just write it first. We are seeing how we can substitute and get to angle 1 congruent to angle 4. So to make sure that you can see that, see it as substitution, right, I can see that that angle 1 could come right here and substitute in for the angle 3. And I can also see that angle 4 can come substitute in for this angle 2. So if I view it like this, I would say, oh, that's substitution. If you wanted to see it as a 3 or more chain, you could call it transitive. So I would take both of them. I initially said substitution, so I'll write substitution. Property of congruence, but I would also argue transitive. So I'm just going to leave it as substitution. It's what I said first. All right, so then lastly, because I have angle 1 and 4 locked into a congruent position, that is what leads me to my parallels. So what kind of angles are 1 and 4? They're alternate interior angles. So I can arrive at my conclusion here in 4. I can say that FR runs parallel to WN. Okay, my reason would be the converse of the alternate interior angles theorem. Okay, so I've written my proof to connect the dots. Okay, in the last one, here I'm saying, well, the starting point is angle 1 and 3 are congruent, and we're trying to build, we were also given that A and R are parallel, and we're trying to build to why is it that B and E must run parallel as well. So again, I'm going to use that same system of just keeping my eye on the prize. What am I trying to connect ultimately? I'm trying to connect B and E. So I'm going to mark those in red, because that's where I'm trying to get to. So if I'm trying to get to those parallels, what must be my transversal? Well, it must be this one ultimately. So when I'm keeping my eye on what I want to connect in the end, I ultimately need to connect 2 and 3. So if I can connect those would be alternate exterior angles. If I can show that those are congruent, that's what's creating this parallel pathway right here. All right, so that's where I'm trying to get to. But what am I starting with? So right now I'm starting with 1 and 3. So what I'm going to do is I'm just going to draw this diagram down below as well. And I'm just going to write that this is my starting point. This is what I want to end with. So I'm just labeling it as start and end. So if I redraw this, I'm just going to sketch it. It doesn't have to be perfect. So here's my starting point, where this is 1, 2, and 3. This was B, E, A, and R. So my starting point is that angle 1 and 3 are congruent. So let me go ahead and mark that. Angle 1 and 3. I'm going to mark that in both places, here and here. So I'm starting with that. And I also know that A and R run parallel. So here these are parallel. How could I build off that? I can build off that if I've used B as my transversal. So again, this is my starting point. And again, sometimes we separate our givens, sometimes we lump them together. I see no reason not to put them together. So I'm going to go ahead and write angle 1 is congruent to angle 3, and line A runs parallel to line R, given. So again, this is where I'm starting, this is where I want to end. So if I'm starting with these are parallels, I can go ahead and link angle 1 to angle 2. I can do that because those are corresponding angles. Angle 1 will link up to angle 2. So I knew that these were parallel pathways, and I know that 1 and 2 have to be congruent. They are corresponding angles. So since I'm starting with the parallels and ending with the angles, that's an original. So here I'm citing the corresponding angles postulate, not the converse. Okay, so since right now I have angle 1 connected to 3 and 1 connected to 2, well, I can circle back and complete that three-way connection. So I can see that it would be angle 2 connected to angle 3. So what I'm seeing first is transitive, so I'm going to write it like that. So transitive, property of congruence. You could also argue substitution because you're plugging in something you know it's the same as. All right, so we've connected 2 to 3 as well. So every angle here is getting a single tick mark. So now remember, this is where I wanted to end. I wanted to end with the diagram on top. So since I now have connected 2 and 3, I've shown that they are congruent angles. They happen to be alternate exterior angles. That is what is locking these lines into a parallel position. So I can reach my conclusion. I can say that line B runs parallel to line E. And my reason would be the converse of the alternate exterior angles theorem. So a good reminder that if we're going forwards, if we know that we have parallel pathways and we're building towards an angle relationship, those are the originals. And if we're going in reverse, if we know an angle relationship and we're trying to build to the lines being parallel or segments being parallel, that is when we are citing a converse. All right, that's all I have for today.